Okay, hello everyone. So today's topic is rotational EMF. We have already covered motional EMF, in which we have derived that whenever there is a rod of length L moving with velocity v in magnetic field B, and if all three are perpendicular, then EMF induced will be BLV. Okay, so now we'll derive rotational EMF. So let us understand what is the meaning of rotational EMF. So suppose we have a rod which is hinged at this point. So the rod is hinged at this point, and suppose this rod is moving with angular velocity omega in this uniform magnetic field B. Now I want to find out what will be the EMF induced between A and B. So what we'll do is we'll use this formula, that is E equal to BLV, where magnetic field is B. And now here we'll see if angular velocity is omega, then at x distance from center, suppose I take a small length element, dx, and the velocity of this small length element will be, since we know that in uniform circular motion v equal to omega r, so velocity of dx will be v equal to omega into x. So on the place of b I'll put b, on the place of L I'll put dx, on the place of v I'll put omega x. Now suppose this rod is moving like this. So basically the rod is moving in uniform magnetic field B, so there will be EMF induced. So what will be the EMF induced? We'll integrate. So for d the limits will be from 0 to e, and for x the limits will be from 0 to r. So by integrating it, the EMF induced between A and B will be B omega r square by 2, where B is your magnetic field, omega is your angular velocity, that is theta upon t, r is radius of the rod. Okay, please remember that the EMF induced is between the center and the outermost point of the rod. And please remember the formula. This formula is very important, that what will be the value of EMF induced when a rod of length L is moving in uniform magnetic field B with angular velocity omega. The EMF induced will be B omega r square by 2, where B is magnetic field, omega is angular velocity, r is radius. Okay, now let us take another case of this question. Suppose in this case, same, the angular velocity is omega, but if you'll see, in this region the magnetic field is 0. So magnetic field is starting from this point and ending at this point. Suppose this length is L by 2, so this length will be L by 2. So in this case, when we'll integrate the formula, we'll take the lower limit to be L by 2, because from 0 to L the magnetic field is 0. So from 0 to L by 2 the magnetic field is 0. The magnetic field starting from L by 2 and ending at L. So the limits will be from L by 2 to L. So you have to integrate this to find the induced EMF. So to put the limits, you have to see where the magnetic field is acting. Okay. Okay. Now suppose there is a question that what will be the EMF induced across a circular plate. Across means the center and suppose the surface. So a circular plate can be divided into infinite number of small length elements. So if you'll see, we can divide this circular plate into infinite number of rods whose length will be r. So whose length will be r, and across each rod the EMF induced will be B omega r square by 2. And if you'll see, all these rods are connected in parallel because the center point is A and the surface is B. So if there are infinite number of EMF whose value is same and they all are connected in parallel, then the equivalent is EMF only. So the equivalent between the center and the surface will be B omega r square by 2. Please remember this formula, that across the center and surface of a uniform circular plate which is moving with velocity omega in uniform magnetic field B, then the EMF induced between center and surface will be B omega r square by 2. So if the disk is moving in magnetic field, then the induced EMF between center and surface will be B omega r square by 2, where omega is angular velocity. Remember, omega is basically theta upon t, that is angle traveled divided by time taken. Okay, so if suppose someone gives you n, that is rotations per second, then omega will be 2 pi n. Please remember this formula. where n is number of rotations per second. So if number of rotations per second are given, then omega will be 2 pi n. Okay, so please remember all this formula and write all these derivations in your copy.